Okay, so for our first question, we're being asked to work out an equation of a line. Now, every line has to be written in the equation y equals mx plus c, where y and x just represent the y and the x coordinates at any given point on the line, and m represents the gradient of the line, which is the steepness of the line, and c represents the y-intercept. So that's where the where the line crosses the y-axis. So we're told that 2, -5 is a point on line A, then we're told 2 points on line B, and we're told that lines A and B are perpendicular. So this is a really important piece of information because the gradients of perpendicular lines multiply to make -1. So the gradients multiply to make -1. And what I can do, because I've been given 2 points of the line B, I can use those 2 points to work out the gradient of line B. So how do you work out the gradient? The gradient is always the change in the y coordinates. So the change in the y coordinates divided by the change in the x coordinates. So let's have a look at this line for line B. We know that the y coordinates are 11 and 5. So we could do 11 take 5 over, and then the x coordinates are 4 and 1. So we do 4 take 1. So the gradient would be 11 take 5 is 6 and 4 take 1 is 3. 6 divided by 3 is 2. So the gradient of line B, the gradient of line B is 2. Now we know that gradients multiply to make -1 if the lines are perpendicular, and perpendicular just means they meet at right angles. So all I have to do in that case is do the negative reciprocal. So I can either think to myself, what multiplies by 2 to make -1, or I do the negative reciprocal. So a reciprocal, all you do to find a reciprocal, you write the number as a fraction. So if it's just a whole number, you write it over 1. And the reciprocal is just when you flip it. So the reciprocal of 2 is 1/2. And the negative reciprocal of 2 would just be -1/2. Okay, so that means that the gradient of our line A must be -1/2. So let's write the first part of the equation. Y equals -1/2x plus c. So we know the gradient. We've been given an x and a y coordinate to -5. So we know on this line, when x is 2, y is -5. So I'll just get rid of the other working as well. So what I can do is substitute those values into the equation to figure out what the y-intercept must be, what c must be. So I know x is 2, y is -5. So -5 is -1/2 times 2, because x is 2, plus c. So what's -1/2 times by 2? Well, 1 times 2 is 2, 2 times 1 is 2. So that would just be -1 plus c. So to find c, I'm just going to rearrange the equation, solve it. So I add 1 to both sides. -5 plus 1 is -4. So therefore c, the y-intercept, must be -4. And I already know that the gradient is -1/2. So therefore the full equation of the line would be y equals -1/2x plus c. Okay, so when we're doing equations of a line, just remember every single line has to be written in the form, if it's a linear straight line, y equals mx plus c, and then work from there. And the key thing is perpendicular lines, their parallels multiply to make -1. If they were parallel lines have the same gradient, so it would have been even easier. So here we've got some linear equations. Slightly tricky one because it's not just a straightforward one. We've got a fraction and something involving brackets. So let's see what we can do. Well, first of all, when I've got something like this, generally I might want to expand the brackets. So I've got 9x plus 8 over 3 equals 2x plus 6. I've just multiplied 2 by x and then 2 by 3. Then what I can do, when I've got a fraction, everything to unfraction the fraction, I just multiply both sides by the denominator. So to turn that into something a little bit simpler, I can multiply both sides by 3, because anything divided by 3 times by 3 becomes itself. So it undoes this division on this side. So I'd just be left with 9x plus 8. And then I multiply each little part on this side by 3. So I could have done that first and said 6 brackets x plus 3, but it doesn't matter, whichever way you find easier. So let's expand that. So I've got 9x equals 3 times 2x is 6x, and 3 times 6 is 18. So now I've got variables on both sides of the equation. When you've got variables, so a variable is just something like x or y, a letter, an unknown value. What I want to do is move the smallest one to the side of the biggest one. So basically I want to have x on only one side in order to solve it. So 6x is the lesser value. So I can subtract 6x from both sides. Remember, to move anything from one side of the equation to the other, you do the inverse operation. So that would become 3x plus 8 equals 18. And then I can subtract 8 from both sides. So I'd be left with 3x equals 10. And then the last step would be to divide both sides by 3. So x would be 10 over 3. Now, this is a non-calculator paper. Don't be afraid if you leave it as a fraction. As long as it's an equivalent value, it's fine. You don't need to then work out 10 over 3 unless it says give your answer to decimal places. So this is absolutely fine to leave it. You could turn it into a mixed number, but you don't have to. Next, we've got an identity. So all an identity means is there are the same thing is being expressed on both sides of the equal sign, but in different ways. So essentially it means that if you simplified both sides, they'd be the same. So an identity would be something like this, because both sides are exactly the same. So let's see what's happening here. We are told that this is an identity, and I need to work out possible values of b. Okay, well, let's see what we can do here. So first, what I want to do, I can see that this is in bracket form. So either I can factorize this or I can expand this side. I'm going to expand the side. So let's see what happens here. So I multiply each term in the first bracket by each term in the second bracket. So x times x is x squared. X times a is xa. 3a times x would be 3. Oh, I've written it in. Okay, so generally, I'm just going to change that. Generally, when you're multiplying terms, it's better to write them in alphabetical order. So xa is the same as ax, but let's stick to writing it in alphabetical order. So that would be 3ax, and that would be 3a squared. So let's simplify that even further. These two, ax and 3ax, are like terms. If they're like terms, we can bring them together. So x squared plus 4ax plus 3a squared is what I'm left with. Now this is equal to x squared plus bx plus 48. So what you have to do is think, okay, which part is equal to which part? Well, x squared is obviously equal to x squared. And then this part here, 4ax, must be equivalent to bx. So I know that if 4ax must equal bx, that 4a must, why does that appear? That 4a must then be equal to b. So whatever b is, it's equivalent to 4a. And similarly, over here, 3a squared must be equivalent to 48. So 3a squared equals 48. Once I know this, I can start solving. So 3a squared equals 48. I'm just going to solve the equation. Start by dividing both sides by 3. So a squared is 48 divided by 3, which is 16. And then I'm going to square root both sides. So a is 4. So I've worked out that the value of a is 4. If I know the value of a is 4, I can use that to work out what the value of b must be, because I know that b is 4a. So b equals 4a. I know that a is 4, so b must be 4 times 4, which is 16. Okay, so work out two possible values of b. Now this is where they're going to get you, and people might think, oh my gosh, I've done this wrong. I should have done something different, like factorizing. No. This is a square number. So every number, if you square root it, it has a positive and a negative root. So we always generally tend to assume the positive root for some reason, but actually I should have written a could be 4 or negative 4. We get into such a habit of just assuming it's the positive. So if b is 4, a, and a is 4 or negative 4, b could be 16 or b could be negative 16, because I could have done b is 4 times negative 4. Okay, so that question nearly caught me out too. We get so programmed to just think of the positive, but every time you are square rooting something, there are going to be two possible roots, the positive and the negative, because negative 4 times by negative 4 also gives you 16. So that's how we do that one. Now over here I have another identity, and this is a slightly nastier one. Once again, remember that all of this must equal x take 5. So as long as I do things to that side of the equation, manipulate it to make it equal, I can find the values. So I've got a nasty looking algebraic fraction. So what I'd want to do first is factorize it and try and simplify that fraction as much as I can. So I know that, let's make life easier for ourselves, I'm just going to start by multiplying both sides of the equation by the denominator to unfraction the fraction, get rid of that. So I'm just working with non-fractions. So multiply both sides by 2x plus 3. I'd be left with x take 5, 2x plus 3. Now let's expand this to see what comes out of it. So x times 2x would be 2x squared. X times 3 is 3x. Minus 5 times 2x is negative 10x. And minus 5 times 3 is minus 15. So also you're going to notice I say minus and negative, I interchange them. It's just a habit taught in an old school way, and I can't undo it. So negative is the right way of saying it, but it really doesn't, you know. So 2x squared, 3 take 10 is going to be negative 7x minus 15. So both of these sides must be equal. So what is equal? Well, I know 2x squared and 2x squared, obviously I can ignore them because they are what they are. I know that b must be negative 7 because bx equals negative 7x, therefore b is negative 7. Oh, and if you didn't know, this little sign here, it means therefore. So it's just a mathematical way of shortening your handwriting. I mean, no one ever writes therefore anyway, but if you wanted to, that's how you'd write it. And then c over here must be negative 15. So your two values are b is minus 7, c is negative 15. So the key thing here is when you see an identity, just see how can I manipulate it? How can I make it so that both sides are in a similar form so that I can see what is equal to what on either side. So here I've got an algebraic fraction and I'm being asked to simplify it. So when you have something like this, you can see that you've got a quadratic above and a quadratic below. Frequently, they're going to have something that is the difference of two squares above. So always look out for the square numbers. So over here, you can see that it's in the form ax squared take away b, and it's in the difference of two squares. So I know that, so that's something easy that I can work out. So the difference of two squares basically just means if you factorized it, I won't explain it, but watch the video on completing two squares if you don't understand. But it's always going to be the square root of, oh gosh. So this would be 3x plus 4, 3x take 4. And the reason for that is because, okay, fine, I'll explain the reason. The reason for that is because they'd simplify out. So let's take let's just do this one as an example. So this isn't the working, this is just an explanation for why the difference of two squares. So multiply that would be 9x squared. Take 12x plus 12x take 16. So with the difference of two squares, because you're multiplying one that is a positive, one that is a negative, the middle two terms are always going to cancel out. So you'd just be left with ax squared take away b. And this only works if they're square numbers. Normally, it would be something like x squared take 16. So it would be simpler. This is a slightly trickier one, but it's still the same case. So it would just be the square root of a, x take square root of b, square root of a, x plus square root of b. Okay, so that's how I do the top part. So the top part is 9x squared. Oh no, I've just deleted everything. Oh well. So the top part is not oh my gosh. Top part is 3x plus 4, 3x take 4. And this is really helpful because when you're simplifying fractions, you're essentially going to look for common factors on the numerator and the denominator. And because it's algebraic fractions, they're not going to be easy things like 3. They're going to be 2 terms in a bracket. So that's really helpful because I know that I'm going to want to factorize my denominator into something that has either 3x plus 4 or 3x take 4. So let's just see what we can do. Well, they're both positive, what I need to factorize. So I'm just going to start with positive. And what are the factors of 20? Okay, so how I'd do this is I'd need to do my little, what's it called? A grid. So factors of 28 are 4 times 7, 28 times 1. 14 times 2. So let's see which of these combine. So I'm going to go for 4 and 7 because, sorry, I always seem to be filming when I'm ill. I'm really ill right now. My brain is going to be working a little bit slower than usual. So I know obviously it has to be 4 because I've just said that. So I'm going to try 7 here. So let's see if that works. 3x squared plus 4x plus 21x plus 28. These two terms always simplify, and do they simplify to 25x? Yes. So therefore I know I've simplified that. Now this is factorizing a trickier quadratic. If you need, there's a video detailing how and why and all of that, so watch that. But I'm just going to factorize this like that. So that would be 3x plus 4, and then my other bracket is x plus 7. Okay, so I've done that. So let's write the fraction out in a nice little fraction thing. So I've got 3x plus 4, 3x take 4, and my denominator I've factorized to be 3x plus 4 and x plus 7. So what do? I cancel out any terms that are the same. If they're being multiplied, which if they are in brackets, that is implied. That's the whole point of the brackets. It implies everything inside it is being multiplied. So I can cancel out any terms that are above and below. So to simplify that fully, my final answer is going to be 3x take 4 over x plus 7. Ooh. So over here, I'm being asked to solve a quadratic. So this one is a quadratic that has a coefficient that is larger than 1, so it's going to be slightly trickier. What I'd recommend to do in a case like this is to draw yourself a little grid. Okay, so I know that I'm going to be factorising it, and it's going to be in the form of 2 brackets. And I know that one of those brackets is going to have to be 2x, because that's the only way you can make 2x by x. So I can write 2x over here and x over here. This will make more sense if you've ever actually expanded a bracket. So if you haven't used this method before, just try. This is how I would expand a certain bracket. So if I had x plus 2, x plus 3, I would write x squared plus 2x plus 3x plus 6. So essentially the x parts are always in the top corner here. And then the second parts of your bracket, so that would be one bracket, and that would be another bracket. These two terms are always going to simplify to make the middle term, and then this one is going to be your number over here. So anyway, that's why I've put 2x and x in that top corner. So essentially this is going to be the top one of the brackets, and this is going to be another one of the brackets. I just need to find the second term, whether it's plus or minus. So I know that this square needs to be negative 24. And I know that these two terms need to sum to make 13x. So I need to think to myself, what are the factors of negative 24? So I could have 8 times 3. Obviously, one of them is going to be negative. I'm just writing the numbers. 12 times 2. 6 times 4. So I know that, and the more you do this, the more you're going to kind of see the number, what's the word? The number, the way the numbers connect. But if you have to draw out this grid 4 times, that's absolutely fine if it means that you get to solve this quadratic. So I know this is going to be 2x squared, and I know these two need to multiply to make negative 13, add to make negative 13. So what two numbers can I combine, bearing in mind, because this is a 2x, one of them is going to be multiplied by 2. Let's just try, just so that you can see that you might get it wrong. I'm just going to try 6 and 4. So I'm just going to put plus 6 and take 4, and I'm going to do this in a different number. So this is, you can do this with a pencil, so like draw the definite things in pen, and then the other bits in pencil, and then you don't even need to keep drawing out. So I've tried 6 and 4. So 6 times x is 6x, 2x times negative 4 is minus 8x. Well, I know 6 times negative 4 makes negative 24, but 6x take 8x does not make 13x. So I'm going to write the ones that don't work. 6 and negative 4 does not work. So maybe I'm going to try negative 6 and positive 4. Let's just rub this out. So that would become negative 6x, and that would become 8x. Once again, 8x and negative 6x. Sorry. Doesn't work. And you could also try switching them around. But now that I've done this a few times, I think to myself, okay, what's the best way that I can make negative 13? Well, I know that double 8 is 16, and 16 take 3 is 13. So maybe I'm going to get a bit smarter with the things that I try. So if I put 8 here, so let's say negative 8 and positive 3, let's see if that works. So x times 3 is 3x, positive 3x, and 2x times minus 8, negative 8, is negative 16x. So negative 16 plus 3 does give me minus 13. So therefore I found my answers. So that would be 2x plus 3 and x take 8. Okay, so I've factorized it. Sorry, that's just the first part of this question. So I've factorized it. And now that I've factorized it, I'm going to need to solve it. So let's just get rid of all this working. So I know that 2x plus 3, x take 8 equals 0. Now, the way to solve a quadratic is step 1, you factorize it, and step 2, you divide by each bracket one at a time. So I'm going to divide both sides by x take away 8. And the reason I do this is because 0 divided by anything gives you 0. So it means that I'm then left with just one of the brackets to work out. So I've divided both sides by that. So I'm left with 2x plus 3 equals 0. So now I've just got a nice little linear equation that I can solve. So 2x, I take 3 from both sides. 2x is negative 3, and then I divide by 2. So x is negative 3 over 2. So one solution is x is negative 3 over 2. Now I'm going to have to do the same, but with the other bracket. So I'm going to divide both sides by 2x plus 3. So that will cancel out. And obviously 0 divided by anything is 0. So I'm just left with x take away 8 is 0. I add 8 to both sides. So x is 8. So my solutions are x is 8 or x is negative 3 over 2. And that's how I do that. Okay, so here I'm being asked to change the subject or to rearrange the formula to make something a subject. So I have variables on both sides, so it's going to be a fun one. And at the end, in order to make something the subject, you just need to get it in the form x equals. So let's see what I can do first, how I can manipulate this to make it slightly easier. So let's expand the bracket first. So I'd have 3 times 5x is 15x. 3 times y is 3y equals 8 plus 17y. I've just expanded the brackets on one side. Now what I want to do is bring all my y terms together. So let's take 3y from both sides of the equation. 15x equals 8 plus 17 take away 3 is 14y. And I want to make x the subject. So all I do is divide both sides by 15. I'm trying to isolate x. So anything that is around x or attached to x, I need to do the inverse. So 15 is multiplied by x. Remember, when a number and a letter are next to each other, it means they're being multiplied. And so therefore, I am left with x equals 8 plus 14y over 15. And that's it. I've made x the subject. I don't need to do anything else. I'm just rearranging everything so I get it in the form x equals. And now we've got a slightly trickier one. So let's see what we do here. So rearrange it to make x the subject. Okay, so first of all, I'm going to multiply both sides by x plus 7. And this is generally what I'd recommend doing if you've got a fraction in algebra. Just multiply both sides by the denominator to make life easier for yourself. So you've got y brackets x plus 7 equals 4x take 5. And I have no clue why it's just decided to go big font, but hey. So this is where it gets a little bit trickier, because I think we're going to have to do some factorizing, but that's fine. So let's expand it. So we've got yx plus 7y equals 4x take 5. The whole point of this is we want to get x on its own. So let's move the x variable to the other side. So let's take 4x from both sides. So I'd be left with yx take 4x plus 7y equals negative 5. And then I can take 7y from both sides. So I'd be left with yx take 4x equals negative 5 take 7y. And now I can factorize. So once I've got x on both sides, you can see that I've got 2 terms that have x in it. If this is what ends up happening, you want to factorize the x out of the bracket. So yx take 4x. If I factorized x out, x times y is yx, and x times 4, or negative 4, is negative 4x. So I can write this now. Let's get rid of all this working. As x brackets y take 4 equals negative 5 take 7y. And I want to make x the subject, so all I need to do is divide both sides by whatever is impacting my x. In this case, the bracket of y take 4. I'm going to divide both sides by that. So I'd be left with x equals negative 5 take 7y over y take 4. We haven't been asked to simplify it, so it's fine to leave it like that. So in this question, I'm dealing with exponential graphs. All that an exponential graph is, it's when something kind of starts off like this and then it rises dramatically. Kind of like the use of the internet. It started off really slowly, people didn't get it, and now it's like boom, 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 and exponentially rising. So shown as the graph y equals 4 to the power of x, and I need to write down the coordinate of the point y. I think it means the point L, because that's the point that has been shown. So the point L is on the y-axis. So every coordinate on the y-axis is in the form 0, y. And I know that y equals 4 to the power of x. So therefore, at the y-axis, x is always going to be 0. So therefore, the y is going to be 4 to the power of 0 because x is 0. And anything to the power of 0 is 1. So therefore, the y coordinate of the point L must just be 1. And that's literally it. Next, we are sketching a quadratic, so slightly harder when we're sketching a quadratic. The first thing we want to do is factorize it. So this is a nice one. So I'm going to factorize it. So what are the factors of 5? Factors of 5 are 5 and 1. And do they add up to make 6? Yes. So this is very nice. So I'm going to factorize it, and it's going to be x plus 5 and x plus 1. And the reason that I factorized them is because when I write it in a factorized form, I can find out the roots, which means where the graph crosses the x-axis. So if I set it, why does it always do that? So if I set it to y equals x plus 5, x plus 1, and along the x-axis, the y coordinate is always 0. So I'm going to say 0 equals x plus 5, x plus 1, because I'm trying to find out where the x coordinates are. Now, the little trick is that it's always going to be the inverse of what's inside the brackets. But if you watched the question a few slides ago, you know that I divide both sides by each bracket. So if I divided by x plus 5, I'd be left with 0 equals x plus 1. So therefore, x is negative 1. And if I divided by x plus 1, I'd be left with 0 equals x plus 5. Therefore, x is negative 5. So my two roots are negative 1. So let's just say that's there. Negative 1 and negative 5. Okay, so that's the roots. The roots are where the graph crosses the x-axis. So let's just write that down. So roots where the graph, why is it so large? Crosses x-axis. This is annoying me. Okay, so I found that out. Now, if I change the colour, maybe it will change. Now, I need to decide whether it's going to be, so any quadratic is going to either look like that or like that. If the coefficient of x is positive, it's going to look like this because it's a positive thing. So I know that's going to be what my graph looks like. And the last bit I need to find out is the turning point. So this is the hard part. The turning point is basically the maximum or the minimum point. In this case, it's going to be a minimum point because it's a U-shaped graph. And to find the minimum point, I'm going to need to complete the square. So when I'm completing the square, what I want to do is x squared plus 6x plus 5. I want to factorize this part. So how can I factorize that? I always halve the coefficient of x. So that would be x plus 3 squared. And I'm just going to do a bit of working out here just to show you what you do. So x plus 3 squared, if I actually multiplied that out, that would give me x squared plus 6x plus 9. So that is the value. X squared plus 6 factorised is x squared plus 6x plus 9. But I want to get x squared plus 6x plus 5. So therefore I think to myself, okay, so from this situation here, how do I get back to 5? Well, I'm going to take 4. So that's what your little extra bit here is for when completing the square. So this is my quadratic in the completing the square form. And essentially, the turning point is the inverse of what we've been presented with. So it's going to be the coordinates negative 3, 4. Negative 4, sorry. So it's the inverse of whatever's inside the bracket. And then this part here, it tells us the the y value. So where would negative 4 be along the y-axis? Over here. Negative 3 is in the middle, which makes sense. So I'm just going to sketch something that looks like that. Okay, and that's all you have to do to sketch it. So that's your minimum point. Negative 3, negative 4. And you've got your roots and you know it's a positive. So that's how you sketch that quadratic. So here I'm being asked to complete a travel graph. I'm told that Emily leaves her house at 9 a.m. and walks at a speed of 4 miles per hour for 45 minutes. So with travel graphs, you're going to generally need to use the formula speed equals distance over time. So, and with a travel graph, your distance is always going to be your y-axis and your time is going to be like the x-axis, and you have to kind of plot that on the graph. So I know that she walks at a speed. I can substitute that in for 4. I don't know the distance, but I know the time is 45 minutes. Now, a really important thing is that I'm not going to write 45 because when I'm doing these calculations, speed always has to be a fraction of an hour. So I need to turn this into a decimal or a fraction of an hour. Well, I know that 45 minutes, well, 45 over 60 can simplify to 3/4. So I'm either going to say divided by 0.75, or I could leave that as 3/4. Now, obviously, this is not like what it looks ugly. You wouldn't do this, but I'm just doing this to demonstrate it. So distance divided by 3/4 is 4. So what I want to do is multiply both sides by 3/4, because at the moment it's being divided by 3/4. So 4 times by 3/4 is going to give me my distance. Well, turn that into a fraction. So 4 times 3 is 12. 1 times 4 is 4. 12 divided by 4 is going to be your distance, which in this case is going to be 3 miles. 12 divided by 4 is 3. Or is that kilometers? Okay, once again, this question, that should say kilometers per hour. Assume that it does. Kilometers per hour. Because on the graph it's kilometers per hour. That should be kilometers per hour too. Okay, so let's plot this. So she's walked a distance of 3 miles in 45 minutes. So she needs to get over here, and 9 to 9:45. So this would be 9:30, and 9:45 would be here halfway through. So we're just going to draw a straight line going from 9 to 9:45. Okay, the next part is she then rests at a coffee bar, and whenever you have a rest, it means that it's going to be a straight line because you're staying stationary, you're not moving any distance. Okay, so anytime you're resting or staying stationary, it's going to be a straight horizontal line. She rests for an hour, so that's going to be until 10:45. So 10:45 is here, so let's draw that. She then continues her journey for 30 minutes at a speed of 5 kilometers per hour. It's just, I didn't change them. So either change this to miles per hour or, yeah, basically just make the graph and this equal. So 5 kilometers per hour until she reaches her destination. So I know that that's going to be 11:15 that she reaches her destination, because that's half an hour. I know the speed is 30. I mean, okay, I'm really feeling quite delirious right now. The speed, I don't know, but I do know that it takes her 30 minutes. And I don't actually need to know the distance because, oh no, she reaches her destination, sorry. So her destination is not back home, it's wherever she's going. So I do need to work I do need to work out the distance. So let's do the same thing. Speed equals distance, which I don't know, over time, which is 0.5. And I do know the speed, it's 5. So to work out the distance, I'm going to need to do 5 times 0.5. Or I could turn that into a fraction, 5 times a half. 5 times a half is going to be 2.5. So it's going to be 2.5 kilometers. So 3 plus 2.5 is 5.5. So at 11:15, she needs to have reached 5.5 kilometers. And that's how I'd show that. So here I have been given some inequalities, and I'm being asked to shade the region that satisfies these inequalities. I'm actually going to change this question. I'm going to say, label the region R that satisfies these inequalities, okay? Just so that I can show you what's not going to work. It just makes it easier for this example, but in the exam you can do it whatever way you work. So on the graph, label the region R that satisfies these inequalities. So first of all, what I want to do is draw these. Imagine they are straight lines. So let's just turn them into normal lines. So that'd be y equals 4, x equals 5, and then over here, let's, well, the whole thing is divisible by 3. So if I divided everything by 3, that'd be y take 2x is less than 4. And then moved that to the other side. So added 2x to both sides. That would be y is less than 2x plus 4. Y equals 2x plus 4. The reason I have done this is because it, when drawing lines like these, you always want to make y the subjects, because that's the form that lines are in, and then you can work out the coordinates and it makes your life a lot easier. So these are the lines that I want to draw. So line y equals 4 is going to be, this is the y-axis, and any line y equals is going to be horizontal, okay? Because at every point on this line, the y coordinate is 4. Similarly, and let's just label that, that's y is greater than 4. So it's greater than 4, it means the region that satisfies this would be anything above here. So that's the region that would satisfy this inequality, but I'm dealing with 3, so I'm going to need to make sure it satisfies the others. So then I've got x equals 5. So I go to this, and the inequality is actually x is less than 5. So I'm going to draw a dotted line. Oh, and I didn't say why you do dotted lines. So first of all, this is the line x equals 5, because at every point, like if I pick that, that would be 5, 7. If I pick that, that would be 5, 12. Every coordinate on this line has the value of x is 5. That's why every x equals line is going to be a vertical line. Now, because my inequalities are less than or greater than, I don't draw a solid line, I draw a dotted line, because that represents that the actual value of x can't be 5. It's only if it was a less than or equal to where I'd be drawing solid lines, but they're all less than or greater than, so they're dotted lines. And in this case, what region would be satisfied? So x, the x coordinate is less than 5, so all of this region here would be satisfied by this inequality. But once again, I'm dealing with 3 of them, so I might just draw an arrow here to remind myself of that. And then I do the last one. So I've got the line y equals 2x plus 4. I'm just going to draw a little, what's it called? Table of values. And I'm going to start with 0, 2, 4, maybe 6. 0, 2, 4, 6. I'm going up in 2s just because I don't want to do every single one. I can. It will make it more accurate. You can, absolutely. It just makes it a bit quicker. So if x was 0, y would be 2 times 0, which is 0 plus 4. So y would be 4. So my first coordinate is 0, 4. My next coordinate, if y is 2, 2 times 2 is 4, plus 4 is 8. So that would be 2, 8, the coordinate. And then if x is 4, y is 2 times 4, which is 8, plus 4 is 12. So the next coordinate would be 4, 12. And yeah, the next one is going to be too big for the grid. So once again, I'm not drawing a solid line because it's a less than. So I'm just going to draw a dotted line over here. And the inequality is less than. So the y values are less than this line. So essentially everything under here would satisfy that one inequality, but I'm doing all 3. So I'm just going to draw little arrows to show that everything under here. So I need to make sure all 3 are satisfied. So it needs to be, let's do it in this colour. It needs to be less, I'm going to shade out what it can't be. So it can't be over here because it needs to be less than this line. It can't be anything over here because of my x line. Actually, I'll shade it in the line that they're doing it. So it can't be anything over here because my x coordinate for over here has to be less than. And it can't be anything over here because of this, because y has to be greater than 4. So the region that it can be is R. Okay, now if the exam told you to shade the region, then you just shade that bit that I've left blank. but I shaded the bits it cannot be just to show you how you can do this question. So here I've got a graph showing the journey of a skydiver. So the graph shows the velocity of a skydiver t seconds after jumping out of a plane, and I need to calculate an estimate for the acceleration of the skydiver at 3 seconds. The way you do this on any kind of velocity time graph, to work out the acceleration at a given point, you draw a tangent to the curve. So this is at 3 seconds, which is here. I'm just going to do a tangent over here, and what I need to do is work out the gradient of the tangent, and that will tell me what the acceleration is. So let's do a nice little line. So let's say maybe from here to here. I draw my little triangle. This isn't going to be super accurate just because it's on the iPad and this pen is really thick. So over here, let's say that is 68. And over here is 40. So my y distance is going to be 68 take 40 is 28. And then over here, I'm going to go from 5 to, let's say, 2. Yeah, that goes to 2. So that's a distance of 3.2. So I need to calculate the acceleration of the driver. So I do the gradient is the change in the y coordinates, which is 28, over the change in the x coordinates, which is 3.2. So 3.2, there's a lot of ways that you can do this. 3.2, I'm going to write that as 3 1/5, and I'm going to say 28 divided by 3 1/5. What's 3 1/5 as an improper fraction? 3 times 5 is 15, so that would be 16/5. And then I'm going to just keep change flip. So 28 times by 5 over 16. 28 times 10 is 280. So 28 times 5 would be 140. So that would be 140 divided by 16. And this is a non-calculated paper. I've ran out of space. But 140 divided by 16 would give you, if we simplified that, I'll just rub this out. Okay, so 140 over 16, let's divide by 2. That would be 70 over 8. Divide by 2 again, that would be 35 over 4. Once you've got that, you can just use a division method. So 35 divided by 4. How many 4s go into 3? 0. How many remainder 3? How many 4s go into 35? 35, 4 times, sorry, 4 times 8 is 35, is 32. So that would be 8. You put your little zeros. What's the remainder? 4 times 8 is 32. The remainder is 3. How many 4s go into... And that wouldn't be a 0 yet. Honestly, I think I need to stop filming because I'm feeling quite delirious. That's not the point here. How many 4s go into 30? 7 is 28. Remainder 20. Remainder 2, which becomes 20. So that would be 8.75. So the acceleration is 8.75 meters per second. Pretty fast, but that's what happens when you jump out of a plane. Okay, next question. Term to term rule for a sequence is times 2 and add 3. The fourth term is this. Okay, so, and we need to work out the second term. Okay, so you've got term 1, term 2, term 3, term 4. To get from the first one to the second one, you times by 2 and you add 3. So the fourth term is 8x plus 53. We need to work out what you do to do the inverse. Well, you times by 2 and you add 3. So therefore, you're going to need to take... Oh, why am I doing it like that? You're going to need to take 3 and then divide by 2. We do the inverse. So 8x plus 53 take 3 would give you 8x plus 50, and then divide that by 2 would give you 4x plus 25. So 4x plus 25 is the third term, and we need to work out the second term. So we do the same thing again. 4x plus 25, I'm going to take 3 and then divide by 2. So I take 3, so that would become 4x plus 22, and then divide by 2, that would become 2x plus 11. And I could keep going, but it's only asked for the second term. So that's it, 2x plus 11. Next, I've got a linear sequence and I'm being asked to work out the nth term. So that's the rule for the sequence. So I need to find an expression in terms of n for the nth term of this sequence. So I've got -4, -1, 2, 5, 8. The first thing I always do is try to work out what the difference is. It's a linear sequence, so there should be it's an arithmetic sequence, so common difference. To get from -4 to -1, you add 3. To get from -1 to 2, you add 3. 2 to 5, you add 3. 5 to 8, you add 3. Okay, so that means that my sequence is going up in the 3 times tables. So I'm going to say the first part is going to be 3n, because it's a 3 times table. It's 3 times whatever is going to give you, like, say this is 1, 2, 3, 4, 5. The sixth term, if I did 3 times 6, that would be 18 in the normal 3 times tables. But what I want to do is write out the normal 3 times tables above. So that would be 3, 6, 9, 12, 15, and then obviously, like I said, this one would be 18. So I know the sequence is going up in the 3 times tables. And if it was the 3 times tables, this is what the sequence would be. However, it has shifted. It's either shifted up or down. In this case, it's shifted down. So how do you get from 3 to -4? You subtract 7. 6 to -1, you subtract 7. 9 to 2, you subtract 7. So it's basically the 3 times tables, but 7 less than that. So that's it. That's how I'd find the nth term of this sequence. So quadratic sequences are a little bit harder, but they follow rules. So let's just have a look at what's happening. I'm told that the first 2 terms of a quadratic sequence are 7 and 16, and then I'm given some further information about the sequence. So I know that the first difference is 9, then 15, then something, and the second difference is 6. And I need to work out the nth term of this quadratic sequence. Okay, so what I'm going to do is use the information they've given me to work out the little missing steps. So +6 + 6. So what's 15 + 6? It's 21. So I know, sorry, that the next step is going to be, the next difference is going to be 21 over here. I'm working backwards. What's 16 + 15? 31. And then what's 31 + 21? That would be 52. Okay, so the sequence is 7, 16, 31, 52. And I know that the second term difference is 6. So for any quadratic, what I do is I work out the second term difference and then I halve that. So let's just do some, there's not much space here really, but let's just do what we can. So quadratic sequences means, unlike linear sequences where they go up in the 3 times tables or the 5 times tables, it's going to be going up in the x squared times tables. So what are the squared numbers? Or let's call it n, because it's asked us to work out the nth term. So the square numbers are 1, 4, 9, 16, 25, 36. Okay, but it's not just going up in the square numbers. It might be going up in something more than just the square numbers. And in this case, you figure out what that is by working out the second difference and halving it. So it's going to be going up in the 3n squared times tables. So all I do, and if the second difference was 4, then it would be the 2n squared times tables. And if it was going up in 2's, then it would just be the n squared times tables. So 3n squared, 1 times 3 is 3, 4 times 3 is 12, 9 times 3 is 27, 16 times 3 is 48, 25 times 3 is 75. So I know that my sequence is going up in the 3n squared. So let's just write it up here. So that would be 3, 12, 27, 48, 75. It's going up in the 3n squared times tables. However, my sequence, oh, that's gone really big. My sequence is not exactly that. It is 7, 16, 31, 52. So the first part of my sequence, just like with the previous one, it's going up in the 3n squared times tables, but it's the 3n squared times tables, and there's a little difference. So it's the 3n squared times tables, but 4 more over here, 4 more over here, 4 more over here. So it's the 3n squared times tables plus 4. And that's how I would work out the nth term of this quadratic. So for your quadratics, work out what the second difference is, because the first difference is never going to be the same. If it was, it would be a linear equation, a linear sequence, and then compare half of the second difference, so halve it, half of the second difference multiplied by the square numbers, and then compare that to your sequence. If this is confusing, drop a comment and I'll make a video on quadratic sequences to explain it in a little bit more depth. So we get a little break from all of the hard questions. We just have a simple expand and simplify. So we want to expand the brackets where we can. So 5 times y is 5y. 5 times negative 2 is negative 10. 3 times 4y would be 12y. And 3 times 5 would be 15. Collect the like terms. So 5y and 12y are like terms. Like terms are just terms that have the same variable. So 5y plus 12y would be 17y, and minus 10 plus 15, or 15 minus 10, would be positive 5. So that's how I do that. Next, I've got an inequality and I need to solve it. So this is kind of similar to what I'd do when I was solving equations. So some people like to just write it out as though it was an equation and then just whack the inequality sign in. But I'm just going to do them both side by side so that you can see how it's exactly the same thing. So with an equation, what would I do? I would, well, first of all, I might subtract 8 from both sides. So let's do the same over here. This is the inequality version. So I'd be left with 7x equals 4x plus 14. And similarly here, I'd be left with 7x is greater than 4x plus 14. Next step, I would subtract 4x from both sides of the equation so that I got my variable on one side. So I do the same with the inequality. I'd be left with 3x equals 14. Here, I'm left with 3x is greater than 14. And the last step would be, I divide both sides by 3. Similarly, I do exactly the same. It's just there's an inequality sign. So here, my answer would be x is 14 over 3. But here, my answer would be x is greater than 14 over 3. So if it makes your life a little bit simpler, you can do this, split the page up, do one as an equation, one as an inequality, or you could solve it as an equation and then whack the inequality symbol in. Or hopefully you understand that this is exactly the same as solving an equation. It's just there's an inequality sign in it. Either way, that would be my answer. This is just an example of what it would be if it was an equation. Do not leave your answer as an equal sign because that is not what you've been asked to do. You've been asked to work out the inequality. So the inequality sign that you've been given must be the same in the answer. Next, we need to write down the inequality represented by the number line. So on a number line, if the inequality is coloured in, then it means it's less than or equal to or greater than or equal to. If the inequality is blank, it means it's less than or greater than. So over here, I've got negative 3, and I know that I've got the inequality is representing x. So x is going to be in the middle because my x values are going to be everything over here. And I've got 5 over here. So I know that my x values have to be in between negative 3 and 5. Now I know my x value could potentially be negative 3 because it's a coloured in dot. It could be negative 2, 1, blah, 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 all of these until I get here, but it can't actually be 5 because this is a blank dot. So So therefore, x must be less than 5. So I'd say x is less than 5. And it must be greater than 3. Greater than or equal to -3. But because I want to write my inequality in one form, saying that x is greater than or equal to -3 is the same as saying -3 is less than or equal to x. So I'm just going to put that there. -3 is less than or equal to x. And that's how I do that. Next, I've got simplifying indices. So over here, what I want to do is just write this out in its own like individual terms. So I've got 6 times a squared can be written as a times a. Oh, b to the power 5 is a lot, but let's do it. B to the power 5 means b multiplied by itself 5 times. So 1, 2, 3, 4, 5. And then that's being timesed by 5 times a times 1, 2, 3, 4. So simplify that. I'm going to multiply the like terms. So 6 times by 5 is 30. Then I've got a squared multiplied by a. So a squared times by a is the same as a times a times a, which would be a cubed. And then I've got b multiplied by itself a lot of times. So b to the power 5 times by b to the power 4. Hopefully you can see that's 1, 2, 3, 4, 5, 6, 7, 8, 9 b's. So that's how I'd write that. And remember, when simplifying, I don't in algebra write the multiplication. So that would be 30a cubed b to the power of 9. Similarly, I've got this little fraction here. So what I'm going to do is write each thing on its own. So that would be 6 times a squared would be a times a, and b to the power 5 would be b, 1, 2, 3, 4, 5. And the denominator would be 3 times a times b to the power of 4. So that would be 4b multiplied by itself 4 times. Now, when you've got a fraction, if all the terms are being multiplied, then you can cancel out anything that is similar on the numerator and the denominator. So b divided by b would just give me 1. Anything divided by itself is 1. That would cancel with that. B divided by b is 1. B divided by b is 1. I've run out of b, so I can't cancel that one. Then a divided by a is 1. And 6 divided by 3. So what I could do is split this up into 3 times 2. So let's get rid of the 6. Actually, let's just write it like this. So 3 times 2, just so that you can see why it would become 2. So the 3 times divided by 3 is going to cancel out. So I'd just be left with, what's the remainder on the numerator? 2 times by a times by b. So that would be 2ab, fully simplified. Okay, now I'm being asked to use approximations to estimate the answer to something. Now, when approximating or estimating, you generally round your figure to one significant figure, unless it's something like a square number, where it makes a lot more sense to round it to the nearest square number. So instead of rounding this to the square root of 99, I'm going to round that to the square root of 100, because that's a square number that I know the square root of. And estimating or approximating, the whole point of it is to make the numbers easy for you to work with, so you can do it in your head or quite quickly. 3.092, I would round to 3 to one significant figure. And then 0.52, I would round to 0.5. Now, be really careful, because this is where a lot of people go wrong. They're like, oh, I'm just going to round it to the nearest whole number. But that completely changes the value of the calculation. So round it to one significant figure. So that would be 0.5. So now I've got easy little numbers to work with. The square root of 100 is 10. 3 cubed, that means 3 times 3 times 3. 3 times 3 is 9. Times 3 again is 27. So 10 plus 27 divided by 0.5. Okay, so 10 plus 27 is 37. And that is being divided by 0.5. Now, how else could I write divided by 0.5 for the calculator paper? I could say that is, the non-calculator paper, sorry, 37 divided by a half. Okay, what do I do when I divide fractions? I keep, change, flip. So that would be 37 times by 2 over 1. and 37 times by 2 is 74. So little trick, dividing by 0.5 is the same as timesing by 2. And that's how I'd do that. So use approximations to get the answer to that. Next, I've got decimal arithmetic. So over here, what I'm doing is I'm multiplying decimals. Now, when I'm multiplying decimals, what I want to do is turn them into whole numbers. And then I can just multiply them like normal. So to turn 0.8 into a whole number, I would times it by 10, and that would become 8. To turn 4.35 into a whole number, I would times it by 100, and that would give me 435. So in total, I've multiplied my equation by 100 times 10 is 1,000. So I've multiplied by my equation by 1,000. So when I get my answer, I'm going to need to divide it by 1,000. But I've multiplied my numbers to turn them into whole numbers, so I can just multiply them easily. And I'm going to use the lattice method because I like it. So 435 multiplied by 8. I divide each little section like that into 2. And then I just multiply the single numbers. So 5 times 8 is 40. 3 times 8 is 24. 4 times 8 is 32. Then I just add along the diagonals. So the first diagonal is 0. 4 plus 4 is 8. 2 plus 2 is 4, and then I've got 3 over here. So I know that 435 times by 8 is 3,480. But I've times my decimals by 1,000 to get to this, so I'm going to need to divide them by 1,000. Now the cheat way that you might know is that whatever your answer is, you count how many digits there are after the decimal point, and that's what you do for your answer. So 4.35 times by 0.8 is going to be 3.480 because there's 3 digits after the decimal point. Or you could do it the proper mathematical way and just divide by 1,000. You choose. Next, we've got some dividing decimals. So we've got 8.2 divided by 0.4. So what we want to do, once again, is turn these, well, at least the second part of the calculation into a whole number. But when we're dividing, we have to keep everything in the same, it needs to be multiplied by the same power of 10. So that would become, if I multiplied both by a power of 10, that would become 82 divided by 4. Now with dividing, it's not the same as multiplying where you have to times it by 1,000 and then divide it by 1,000. With dividing, there's actually something different that happens. So let's just have a look at what happens if I said, what's 80 divided by 40? That's 2. What's 8 divided by 4? That's also 2. What's 0.8 divided by 0.4? That's also 2. So with division, as long as you've multiplied both parts of the calculation by the same power of 10, your answer will be the same. So 8.2 divided by 0.4 is going to be the same as 82 divided by 4. So let's work out 82 divided by 4. How many 4s go into 8? 2. How many 4s go into 2? 0. Remainder 2. So when I run out of numbers, I put zeros, loads of zeros, and I put the decimal point. How many 4s go into 25? So 82 divided by 4 is 20.5. So therefore 8.2 divided by 0.4 must also be 20.5. And think to yourself, when I'm dividing by something, it means how many times does that thing fit into that? So there's roughly 20 lots of 0.4 in 8. So just double check to see if it makes sense. So here I'm being asked to simplify something, write it as a fraction in its simplest form. And the two things I've been given are in different units. So one is in millimeters and one is in kilometers. So it's really important that I use my conversions here. So 750 millimeters is a fraction of 0.4 kilometers. Either I can convert the millimeters to kilometers or the kilometers to millimeters. I'm going to go the second way round. So let's try and convert 0.4 kilometers to meters first. Well, I know that 1 kilometer is 1,000 meters. So 0.4 kilometers, what do you do to turn kilometers to meters? You multiply by 1,000. So 0.4 kilometers is going to be 400 meters. I then need to turn meters into centimeters. So I know that 1 meter times by 1,000, 1 meter is 100 centimeters. So I need to turn 400 meters into centimeters. So what do I do to turn meters to centimeters? I times by 100. So 400 times by 100 is going to be 40,000. So 400 meters is 40,000 centimeters. And last step, I need to convert 40,000 centimeters into millimeters. I know that 1 centimeter is 10 millimeters. So 40,000 centimeters, I'm going to multiply by 10. I'll try the pink one. So times by 10 to turn centimeters into millimeters, and that would give me 400,000 millimeters. So I know that 0.4 kilometers is 400,000 millimeters. So let's write 750 over 400,000, and let's simplify it. Well, let's divide it by 10 first. So that would be 75 over 40,000, and then I can divide it by 5. So how many 5s go into 75? I'm just going to rub this working out. How many 5s go into 75? This is non-calculator, so we have to work it all out manually. 5s into 75, 5s into 7 go 1, remainder 2, 5s into 25 are 5. So that would be 15. So I'm dividing by 5. Here I divided by 10. Then I need to figure out how many 5s go into 40,000. How many 5s go into 4? 0. So remainder 4. How many 5s go into 40? 8. So that would be 8,000. So 15 over 8,000. Oh, I could have just divided it by 25. Oh well, let's divide it by 5 again. Ooh. So divide by 5, divide by 5. 15 divided by 5 is just 3. And 8,000 divided by 5. How many 5s go into 8? 1. Remainder 3. How many 5s go into 30? 6. So that would be 1,600. And 3 divided by 1,600. Can I divide everything? So if I divided everything by 3, that would give me a non-decimal number. So that would be in its simplest form, because 1,600 does not divide by 3. So now I've got a little bit of fractional arithmetic. I'm told there are 400 students in year 7, 160 of which are boys, 450 students in year 8, 200 of which are boys. Who has the greater proportion? So proportion just means like the amount out of the total. So I need to compare the amounts as fractions. So year 7 is 160 out of 400. So I'm going to want to simplify that. And year 8 is 200 over 450. So let's see. I could either simplify it or I could divide it, depending on what you find easier. But let's simplify first. So if I divide by 10, that would be 16 over 40. Divide by 2, that would be 8 over 20. Divide by 2 again, that would be 4 over 10, which would be 2/5. So 2/5 as a decimal would be 0.4. And if you didn't know how to do that, 2/5, that would 2/5. What does this line here mean? It means divide. So 2/5 means 2 divided by 5. So you'd say, how many 5s fit into 2? 0, remainder 2. How many 5s fit into 20? 4. So that's how you turn a fraction to a decimal. So that's 0.4. Year 8, let's simplify that. So that would be 20 over 45 if I divided by 10. Then it's 45. Then I could divide by 5. So 20 divided by 5 is 4. 45 divided by 5 is 9. So that would be 4/9, and I can't simplify that any further. So let's turn that into a decimal. So 4 divided by 9. And remember to decide which one goes first. So when you're doing like 4 divided by 9, it's always the second number that goes outside the bus stop. You can think of it as us being in rainy England. It's always raining. So whoever gets first to the bus stop gets to wait inside. Whoever gets the second has to wait outside. So how many 9s fit into 4? 0. Remainder 4. So I'm going to put my decimal places. How many 9s go into 40? How many 9s go into 40? So 4 times 9 is 36. So that would be 4 remainder 4. And then it's going to be a recurring fraction because from 36 to 40 there's 4, so it's just going to be 0.444444 recurring. So which year has the greater proportion of boys with 0.4 recurring is greater than 0.4? So that would be year 8. Now here we've got finding the original fraction. So we're told that 3/5 of a number is 45. Work out the number. So if I've got my number and it's been split into 5 parts, because that's what I've been told, 1, 2, 3, 4, 5, 3/5 of that is 45. So I know 3/5 of this number is 45. So if I did 45 divided by 3, I could figure out how much 1 part is. And 45 divided by 3 is 15. So each part of this fraction, each fifth, or I could have done it like the fractional way if you don't like the picture method. So 1/5 must be 15. To work out the whole number, I need to work out 5/5. So either multiply 15 by 5, or I could do it like this in the little picture, because pictures are just a lot more fun. So 45 plus 30 would give you 75. So the original number is 75. And that's how we do that. Now I'm writing a value as a fraction of another. So Greta is 2 years and 10 months old. Ivan is 1 year and 4 months old. Write Greta's age in months as a fraction of Hugo. I think that's meant to say Ivan in months. So let's turn them into months first. So 1 year has 12 months. So 2 years would be 24 months. So therefore Greta would be 24 plus 10, which is 34 months old. And Ivan is 1 year, which is 12 months, plus 4, which is 16 months old. So write Greta's age in months as a fraction of Ivan's age in months. And give it in your simplest form. Well, Greta's age is 34, Ivan's is 16. So let's simplify it by dividing both by 2. That would be 17 over 8. And I can't simplify that any further. So that's how I'd do that. Right, so here we're being asked to prove algebraically that something can be written in a different form. So I'm dealing with recurring decimals, and they've actually told me what my answer should be. So if I go wrong and I get a different answer, I know I can just redo it and try again. So let's start here. So prove algebraically means I'm going to start with my value being x. So 0.193 recurring. Now, the whole point of doing this is I'm giving my original value, I'm trying to turn that into something that can be cancelled out. So if I turned it into 10x, if I multiplied that by 10, that would give me 1.93 recurring. And a lot of people, this is where they go wrong, because they're like, okay, I'll multiply that by 10, so then they subtract it. But the whole point is that when you're subtracting, you're supposed to get things that cancel out. So if that's 10x, that doesn't work, because you'd be subtracting things that are not the same. The bit after the decimal point has to be exactly the same. So in this case, we're going to aim to get the bit after the decimal point as 0.93 recurring. So let's try 100x. That would be 19.39 recurring. Again, that doesn't help me. So let's try 1000x. That would be 193.93 recurring. So what I can see is that the bits that have 0.93 recurring are 1000x and 10x. So I'm then going to write those out like this. So 1000x is 193.93 recurring, and 10x is 1.93 recurring. If I subtracted them, I'd be left with 990x equals, and the whole point that I do this is because this just cancels out. 193 take away 1 is 192. So 990x is 192. Now let's solve it. So I'm going to divide both sides by 990. So x would be 192 over 990. Now I know I need to simplify this, so perhaps I can start by dividing by 2. So 192 divided by 2 is going to give me, so 96. And 990 divided by 2 is just going to be 495. Now I know I need to get that to 32. So 96, how many times does 32 fit into 96? Well, that would be 3 times. So if I divided everything by 3, that should take me there. So I've shown that I've divided it by 2 first, and then I'm going to divide by 3. So 96 divided by 3 is 32, and then 495 divided by 3 is 165. So that's how I'd show that. You might want to do your working like this, so do it all alongside. So you might want to say x is 192 over 990, and then show what you've done. So you divided it by 2, so it was 96 over 495. So you've got your working out like that, and then show that divided by 3, because it's a prove algebraically. So that would just make sure that you cover all areas, but either way is fine, and that's how you do that. Okay, so here I'm being asked to deal with a percentage multiplier. Now, all a percentage multiplier is essentially the percentage represented as a decimal. So, for instance, if I wanted to increase something by 10%, I'd start off with 100%, and I'm increasing it by 10%. So in total, I've got 110%. And then what does percentage mean? It means divided by 100. So 110 divided by 100 is 1.1, and that is my multiplier. Okay, so all a multiplier is how the percentage is represented as a decimal. So what multiplier is used to calculate a percentage decrease of 6.9%? So the important thing is we always start with 100%, because that is the value that we start off with. Our original value is 100%, and then it's a decrease. So I'm going to take 6.9% away from that. So 100 take away 6.9 is going to give me 93.1. 93.1%. Now, what does percent mean? It means divided by 100, or over 100. So 93 divided by 100 is 0.931. So the percentage multiplier is 0.931. Now for the second question, it's saying the value x is increased by 20% to give the value y. Okay, so a percentage increase of 20 would be 100 plus 20, which is 120%. Percent means divided by 100. So as a multiplier, that would be 1.2. The value y, so x times by 1.2 gives you y. And then the value y is then increased by 40% to give the value z. So this is then multiplied by, what's 100 plus 40? So let's work out a percentage increase of 40. That would be 100 plus 40, which is 140%. And percent means over 100. So 140 divided by 100 would be 1.4. So x is multiplied by 1.2. That gives you y. So this part here is y, which is then increased by 40%, so multiplied by 1.4 to give you z. So all of this is how you'd get z, and you need to write down the multiplier that is used to calculate the overall increase. So x is being multiplied by 1.2 and then by 1.4. So I need to essentially figure out what 1.2 times 1.4 is. Now I'm just going to use the lattice method to do that. So turn it into whole numbers. So 12 times 14 is 2 times 1 is 0, 2. 2 times 4 is 0, 8. 1 times 4 is 0, 4. 1 times 4 is 0, 4. So that would be 8. 4 plus 2 is 6, 4. So 12 times 14 is 468. And 1.2 times 1.4 would be 4.68 because there are 2 digits after the decimal point. Times 14 is not, what did I do wrong? Oh, 1 times 1. Sorry, that's 1. Let's just change that. 1 times 1 is 1. I don't know why I put 4. Okay, so 12 times 14 is 168. 1.2 times 1.4 is 1.68. So therefore, the overall increase from x to z is 1.68. That's the multiplier that would take you straight from x to z. Okay, so here I am dealing with the laws of indices. The first question is asking me to write down the value of 178 to the power of 0. Now, anything to the power of 0 is always going to be 1. There's loads of videos explaining why, but really quickly, let's say you had 2 squared, 2 to the power of 1, 2 to the power of 0. What's 2 squared? 4. 2 to the power of 1 is 2. Let's even throw in a 2 cubed there. Each time I'm dividing by 2. So therefore, maths follows loads of patterns, and this is such a case. So if you divide by 2 again, you would be left with 1. And that's the case for anything. If it was 3 to the power of 0 to follow this pattern, it would always be dividing by 3. So that's why anything to the power of 0, and if you didn't know this, just write it down as a key reminder, anything to the power of 0 is 1. Always. Okay, next we've got 3 to the power of 9 times 3 to the power of 7, negative 7. Okay, so quick rule recap. When you are multiplying indices, so let's say you had 3 to the power of n times 3 to the power of m, you would do 3 to the power of n plus m. Okay, so here I'm multiplying, so I'm going to do 3 to the power of 9 plus negative 7. And when you're dividing, so let's say 3 to the power of n divided by 3 to the power of m, you subtract them. Okay, so first let's do this. So 9 plus negative 7 is the same as 9 take 7, so that would be 3 squared. So I'd be left with 3 squared divided by 3 squared. So I could do 3 squared divided by 3 squared like that, and I'd end up with 3 to the power of 0, which is 1. Or you might know that anything divided by itself is just 1 and do it that way, whichever works best with your way of thinking. So the value of n is 1. And then next question, I know 2y times 2 to the power of 2y is 2 to the power of 12. So once again, using these rules, I therefore know that 2y times 2 to the power of 2y is the same as 2 y plus 2y, okay? And that must equal 2 to the power of 12. So I know that y plus 2y must equal 12. So therefore, 3y equals 12. So y must equal 4. Now it's asking me to work out the value of 2 to the power of 4y. Well, if y is 4, that would be 2 to the power of 4 times 4, which is 16. And 2 to the power of 16 is a really large number, so I think that this wouldn't be on the non-calculator, but you just keep multiplying by 2 and you'd end up with 65,536. But just for the purposes of this, they wouldn't ask you for the value, they just probably say work out the value of, I don't know what they meant, but that's how we do that question. Next, we need to write down the value of 8 to the power of 8 to the power of 2 over 3. So whenever you have anything to the power of anything, so let's say it was like that, this is what it's going to be to the power of, and this is what it's going to be to the root of. So in this case, I've got 8. I need to do the cubed root of 8, and then that's going to be squared. So what's the cubed root of 8? The cubed root of 8 is 2. So that's going to become 2 squared. And 2 squared is... And then over here we have a negative, or something to the power of a negative indice. When it's a negative indice, so if it was something like 5 to the power of negative 3, all that means it's 1 over, like what the positive would be. So the negative just means it's 1, it's reciprocal. So 5 over 2 to the power of negative 3 is going to be 1 over 5 over 2 cubed. So therefore, let's figure out what 5 over 2 cubed would be. Well, that would be 1 over 125 over 8. And we can't leave it like this. We have to work out the value. So we're doing 1 divided by 125 over 8. What do you do when you divide fractions? You keep change flip. So that's 1 times by 8 over 125. So that would be just 8 over 125. That's the value. And then for the last one, we've got work out the value of 3 to the power 15 divided by this. So when you've got powers in brackets, so we could write that out like 3 squared times 3 squared times 3 squared, because cubed means multiplied by itself 3 times. We could then further write that out like this. So if you're stuck and you forget the rules, I would encourage you to do that. So just write it in its simplest, like what does it actually mean? Well, it means 3 squared times by itself 3 times. Or the rule is you multiply the numbers inside and outside the brackets, the indices. So that would become 3 to the power 15 divided by 3 to the power of 6. And when you're dividing indices, you subtract the powers. So that would become 3 to the power 15 take 6, which is 3 to the power of 9. And it says write the value, but it's a non-calculator paper, and I don't think they would expect you to write that out, but just for peace of mind, it's 19,683. Okay, so here I've got a slightly trickier one. So given that 16 to the power of negative a half is 64 to the power of a third divided by 4x plus 1, I need to find the exact value of x. Now, remember that a negative indice means it's going to be a reciprocal. So it means it will be 1 over 16 to the power of a half. And now let's work out what 16 to the power of a half is. Remember this part over here, if it was like an over m, that would be the root, and that would be to the power of. So that means 16 to the power of a half is the same as the square root of 16. And the square root of 16 is 4. So therefore, 1 over 16 to the power of a half is the same as a quarter. So 16 to the power of negative a half is this, which is equal to that. So a quarter must be equal to 64 to the power of a third divided by 4x plus 1. Now 64 to the power of a third, I apply the same rules. It's going to be to the root of. So 64 to the power of a third is the cubed root of 64, which is 4. So a quarter equals 4 divided by 4x plus 1. Okay, so let's think about this. Now, I can write this as in another way, just so that you can maybe see what's going on. So I could write it like that. Okay, so these need to be equivalent fractions. Now, a quarter equals 4 over something. What must that something be? Well, 4 divided by 16 is a quarter, because this is, if you divide it by 4, it's an equivalent fraction. So therefore, I know that 16 must be equal to 4x plus 1. Okay, and 4 to the power of what gives me 16? Well, 4 squared is 16. So therefore, x must be 1, because 4 to the power of 1 plus 1 is 4 squared. So the exact value of x is 1. Moving on to standard form. Here I'm being asked to write a number in standard form. Now, to write any number in standard form, it needs to be the number, and the number needs to be between 1 and 9.9. So it needs to be a single digit number. It can have like decimals after it, but single digit, like it can't be 99, it can't be 45. It needs to be a single digit and then decimals after it. So a number times by 10 to the power of something. So I need to turn this into a single digit like number. So that would be 6.975. And then I need to think, okay, so 6.975 times 10 to the power of something gets me back to here. Well, generally, I'm just going to show you the cheat way because I'm feeling quite ill. So you count how many digits there are after your first digit. So there's 1, 2, 3, 4, 5, 6. So that's 6.975 times 10 to the power of 6. I will explain it because now I feel bad. Basically, you think about what power of 10. So 10 to the power of 1 is just 10. 10 squared is 100. 10 cubed is 1,000, and so forth. So you could try it out. 6 times 10 to the power of 1 would just be 69.75. So 10 to the power of 1. If you did it 10 squared, it would be 697.5. If you did it 10 cubed, it would be 6975. So you can just do it that way and keep on going, but the trick way is count how many digits there are, and that tells you what power of 10 that it needs to be. And then similarly, we need to write this as an ordinary number. So ordinary number means it's not written in standard form, it's just one number to the power of negative 10. So similarly, if we had 10 here, 10 to the power of minus 1 is 0.1. 10 to the power of minus 2 is 0.2. So when we're dealing with to the power of a negative, it's slightly different. So 5.28 times 10 to the power of negative 3. Sorry, I was supposed to say 0.01. 0.001 is basically, I'm saying 5.28 times by 0.001. Now, if you remember, when we multiply any number, we can turn it into a whole number. So I could do that as 528 times by 1, which is 528. And then what I do is I say how many digits are after the decimal point. So that would be 0.12345. There's 5 digits after the decimal point. So 1, 2, 3, 4, 5. So my whole number has to have 5 digits after the decimal point. So I could do it that way. Or the cheat method, once again, is you say to yourself, okay, it's times 10 to the power of negative 3. So I'm going to count 1, 2, 3 zeros and then start writing my number. And the first 0 is included before the decimal point. So that's another way you could do that. For C, it says work out 3 times 10 cubed times 5 times 10 to the power and write your answer in standard form. Now, because all of this is being multiplied, I can just multiply everything however I like. So I can just write it like this. So I could do 3 times 5, which is 15. And then 10 cubed times 10 to the power of minus 4. When you multiply indices, that would be the same as saying 3 plus minus 4. So that is minus 1. So that would be 15 times 10 to the power of minus 1. Now, the trick here is that they've told you to write your answer in standard form. And this is where a lot of people are like, oh yeah, I worked it out and it's fine. It's not fine because they ask you to work it in standard form. So 15 times 10 to the power of negative 1. I need to write that in standard form, which means this needs to be 1.5. So what I've done is I've divided that by 10. Now let's, just so that you can see what's happening, 15 times 10 to the power of minus 1 is the same as 15 times by 0.1, which would be 1.5. So when you're dividing by 10 on your number, you're going to have to times by 10 on your powers. So that would become 10 to the power of 0. Why has it gone so big? So in standard form, it would be 1.5 times 10 to the power of 0. But generally, we don't write 10 to the power of 0 because that's just 1. So we could just leave it as 1.5. And that's how we do that. Cross that, ignore what I just said. It asks you to give your answer in standard form, so you would leave it as 1.5 times 10 to the power of 0. Okay, right, next question. Okay, here I am being asked to calculate with numbers in standard form, and unfortunately they're not all being multiplied, they're being added, so I'm going to need to work them out separately. So 7.23 times 10 to the power 4, that would be 7, and then 1, 2, 3, 4 digits. I'm just doing the cheat way because it's quicker. Plus 2.37 times 10 to the power 5. So I write my first digit and then 1, 2, 3, 4, 5. So I need to calculate this. So I'm going to actually need to add these two values. So 72,300. Let's add them together. That's 0, 0, 3, 9, 10, 3. Okay, so you work them out individually and then you add them, and then you're going to have to rewrite it in standard form. So 309,300 in standard form is going to be 3.093 times 10 to the power of 1, 2, 3, 4, 5. And that's how I'd do that question. Next I've got surds. So multiplying surds, I do this just as I would if I was multiplying brackets. So perhaps I'm going to start with a little grid just to make life easier. So the first bracket I'll put up here, 3 plus root 8. And the second bracket I'll put along here, so 5 take root 12. So 3 times 5 is 15. 5 times root 8 is 5 root 8. 3 times negative root 12 would be minus 3 root 12. And negative root 12 times by root 8 is going to be negative root 72. No, 12 times 8 is 96. Okay. Okay, so let's simplify this where we can. Right, remember when simplifying surds, we're always looking for a square number. So 1, 4, 9, 16, 25, 36, 49 are my square numbers. And over here, I know that these two are going to eventually simplify, but let's just write it out so you can see what's happening. So I've expanded the bracket, so 3 times 5 plus, take 3 root 12 plus 5 root 8, take root 96. Now I need to simplify each of these. So let's start with the first one, 3 root 12. So root 12, find the largest square number that fits into that. That would be 4. So I could write that as root 3 times root 4, which is root 3 times by 2. So that would be simplified to 2 root 3. So that would be 15, take away 2 root, except I've got 3 lots of this. So I've got 3 lots of root 12. So 3 root 12 is going to be 3 lots of 2 root 3. So that would be 6 root 3. So that's 6 root 3. Now let's simplify the next part. So you do it all bit by bit. It's going to be a lot of working out, but hey, what can you do? So you've got 5 root 8. Let's just simplify the root 8 part first. So root 8, look for the largest square number, which in this case is going to be 4. Square root of 4 is 2, so that would be 2 root 2. Except you want 5 lots of root 8. So you want 5 root 8 is the same as 5 lots of 2 root 2. 5 times 2 is 10, so that would be 10 root 2 plus 10 root 2. And then let's see if we can simplify root 96. So root 96, we're always looking for the largest square number that fits into your surd. So in this case, 16 is going to fit into here. So root 96 can be written as root 16 times by root 6. And the square root of 16 is 4, so that's 4 root 6. So that would be take away 4 root 6. Unfortunately, you can't simplify this any further, sadly. But what can you do? That's just what happens. So that's how you expand it. And unfortunately, you need to simplify each little part of the surd. Hopefully in the exam, they give you a slightly nicer one where the term simplify, but that's how you do that. And in this question, I'm being asked to write 6 root 50 in the form a root b. So essentially, I'm just simplifying this. So let's have a look at what this means. So just like in algebra, when a number and a letter are next to each other, when a number and a surd are next to each other, it means they're being multiplied. And root 50, when I'm simplifying surds, I want to try and find a square number that is a factor of the surds. So root 50, let's just deal with root 50 to begin with. Root 50, what's the largest square number I can think of that fits into 50? That would be 25. So I could write that as 25 times by 2. So essentially find the factors of 50, one of which should be a square number. So I could write that as, I could split the two surds up and it would still mean the same thing. 25 times by root 2. Now I can actually work out what root 25 is. That would just be 5. So that would be 5 root 2. So 6 times root 50 is going to be 6 times by root 50 is the same as saying 6 times 5 times root 2. So 6 times 5 is 30. So that's the same as saying 30 root 2 times root 2, which I could simplify to 30 root 2 over all. And here I am rationalising the denominator. Kind of itchy face. So when I'm rationalising the denominator, all that means is that I don't want the denominator to be in surd form anymore. So to do that, I multiply both the numerator and the denominator by whatever the denominator is, unless it's a two-term thing in which it's a conjugate, but that's something different. So I'm going to multiply by the root of 7, because in order to keep a fraction equivalent, I need to multiply. Like if I had 2/3 and I multiplied it by 4, that would become 8 over 12. Sorry, that should say equals. So 2/3 is the same as 8 over 12 because I've multiplied both the top and the bottom by 4. So as long as I multiply the numerator and the denominator by the same value, the fraction is going to stay equivalent. It's going to be the same thing that we're dealing with. So let's just multiply that. So 7 times by root 7 is 7 root 7. And root 7 times root 7, well, anytime you multiply a surd by itself, it like unsurds itself. So that would just be 7. Now, I'll just quickly show you why. So let's do it with 25, for example. So the square root of 25 times the square root of 25. We know this one because we know that square root of 25 is 5. And we know that 5 times 5 is 25. So this is just how you can kind of visually see it and remember. But yeah, so I've got 7 root 7 over 7, and it says give your answer in its simplest form. So remember, when anything is being divided, when anything is on the top and the bottom of the fraction, so on the numerator and the denominator, it cancels out. So 7 divided by 7 is just 1. So that would leave me with just root 7. And I've got a really itchy nose, so I'm just going to pause there. So in this case, I'm rationalising the denominator of a slightly trickier surd. So it's got 2 terms on the denominator. And whenever that is the case, what I need to do is multiply by the conjugate. And all that means is whatever the 2 terms are, the sign in the middle, I switch it. So if it's a negative, I switch it to a plus. So in this case, I'm going to multiply both numerator and denominator by 3 root 5 plus 2 because it's the opposite. Now the reason I do this is because the 2 middle terms cancel out, so the surd parts cancel out. But if you want to know more, or if you're struggling on this, watch the video on surds and rationalising the denominator. Right, so let's multiply everything. So I've got that would become root 5 times by 3 root 5 plus 2, and the denominator would be 3 root 5 take 2, 3 root 5 plus 2. So let's multiply it out bit by bit. Root 5 times by 3 root 5, sorry, I've got a really itchy nose. Okay, so root 5 times by 3 root 5. So root 5 times by 3 times root 5. Root 5 times root 5 is going to just become 5. So that becomes 3 times 5, which is 15. So that becomes 15. And then root 5 times by 2 is 2 root 5. Over here, we've got 3 root 5 times by 3 root 5. So let's just write that out like this. So 3 times 3 is 9. And root 5 times root 5 is just going to be 5. So that will be 45. And then 3 root 5 times by 2 is just going to be plus 6 root 5. Take 6 root 5. Take 4. Okay, so going through this quite quickly. My nose is really itchy, so I need to just like go and do something. So basically these 2 terms cancel out because plus anything minus something, like plus 5 take 5 gives you 0. So you just be left with 15 plus 2 root 5, and then 45 take 4 is 41. So that's how you show that. And that's what the question asked us. Something, take something to the root 5 over something else. A is 15, B is 2, and C is 41, but they haven't asked you for that. Okay, so here I'm being asked to work out the surface area of a prism. Now, when we think about surface area, if you think about like when you get to Christmas or birthdays, and when you wrap someone's presents up, so the surface area is literally all the parts that the paper would go over. So what helps to do when we're doing surface areas to draw the faces so that you know what you've got. So here I'm trying to work out the surface area of this triangular prism. So I'm going to have this face over here, which is 4 by 5. Next face, I'll do it in a different colour. I'm going to have these 2, the front and the back. Okay, so these 2 faces there. So I'm going to have 2 triangles that have a base of 4 and a perpendicular height of 10. What else do I have? I'm going to have this side here, and then this as well here. So like 2 little rectangles that have a length of 5 and a height of 7. So I've got 2 lots of those. Okay, so that's what I would recommend you do when you're working out the surface area of anything. Draw out the separate faces and then work out the area of them individually, and then just add them. So in this case, for the first one, I've got 4 centimeters times 5 centimeters, so that would be 20 centimeters squared here. I'll just write it there, 20 centimeters squared. And then here we've got 2 triangles. So how do you work out the area of a triangle? Is base times by perpendicular height divided by 2. So I'm going to do 4 times 10 divided by 2, which is 40 divided by 2, which is 20 centimeters squared again. And there's 2 of them, and they're identical. So that's going to be 2 lots of 20 centimetres squared. And then for the slant edge, I've got 7 times 5, which is 35 centimetres squared, and 35 centimetres squared here. So that's how I'd do that. And now all I'm left to do is just add them all up. So 20 plus 20 plus 20 is 80 centimetres squared, and 35 plus 35 is 70 centimetres squared. So in total, that's going to be 150 centimetres squared. And that's how I'd work out the surface area of that prism. So always just start by working out what the individual faces are, and then work out the area of that and add it all together. Total surface area is literally the area of each face added up. And that's that. Okay, so here you're being asked a question on exact trigonometric values. Now you might know them off by heart, but if you don't, I'm going to show you a way that you can work it out in the exam. So there are 2 triangles that you need to remember for exact trigonometric values. One of them is the equilateral triangle where the side length is 2 and then each angle would be 60 degrees. But that's if you're trying to work out cos 30, cos 60, sine 30, sine 60. So that's not relevant today. The one that we're going to use today is an isosceles right angle triangle of side length 1. So we've got a right angle triangle and one of the angles is 45 degrees. Now if one of them is 45 degrees, that means that the other one's going to be 45 degrees as well, because angles in a triangle sum to 180. Now sine 45, I need to try and work out the exact value of that. So using my SOHCAHTOA, what does sine, what does SOH stand for? Well, sine theta is opposite over hypotenuse. So what I want to do is figure out what the length of my opposite side is and what the length of the hypotenuse is. Now I don't know what the length of the hypotenuse is yet, but I can work that out because I know Pythagoras. So with Pythagoras, I know a squared plus b squared equals c squared. So therefore 1 squared plus 1 squared must equal c squared. So 2 is c squared, so therefore c squared is 2 and c must be the square root of 2. So this over here must be the square root of 2. So if I'm trying to work out sine 45, I need to know the opposite, and let's say this is the angle that I've been given. So sine 45, the opposite side is over here and the hypotenuse is over here. So therefore sine 45 is going to be opposite, which is 1, and the hypotenuse, which is root 2. So the exact value of sine 45 is 1 over root 2. If that's confusing, then don't worry, because I've gone over that really quickly. And just let me know if you want me to make a video on how to do that in more detail. For next question, we are told that cos 60 is 0.5 and I need to work out the value of x. Okay, so I need to work out the value of x. Let's label each side. So this is the angle I've been given. This therefore is going to be the opposite side. This is the adjacent, and that's the hypotenuse. I don't know why that's gone so big. Let's change colour, that might help. So what is cos? So out of SOHCAHTOA, you've got SOHCAHTOA, and ka means cos theta is adjacent over hypotenuse. So I know that cos 60 is adjacent x over hypotenuse 14, and I also know they've told me that cos 60 is 0.5. So 0.5 is x over 14, and therefore if I multiply both sides by 14, x is going to be 14 times by 0.5, or 14 times by a half, which is 7. So x is 7. So all I do is I substitute the values that I've been given into the trigonometric ratio that I'm using. In this question, I'm dealing with a sector of a circle. Now, all a sector of a circle is a chunk, a part of a circle. So if you know that your whole circle is this, and you know that the area of a whole circle is pi times radius squared, then a sector of a circle, let's say a quarter of it, is going to be pi r squared times by a quarter, because it's a quarter of a circle. So what we want to do is figure out what the angle is, and then we can figure out something to do with the area. So I'm told that XYZ is a sector with a radius 5 and area 5 pi, and I need to work out the size of the angle. So like I said in this formula, the area of the whole circle would be pi times radius squared, which is 5 squared, multiplied by the fraction of the circle. So I don't know what this angle here is. I'm just going to call it theta, or actually to make it easier, I could call it, no, I'm just going to stick. So theta, if you haven't come across it, theta is just a symbol for an angle. Okay, so theta over 360, because there's 360 degrees in a circle. So I know that the area of that circle is 5 pi, and that 5 pi is the area of the circle times by the angle over 360. So let's simplify that. So 5 pi must equal, well, 5 squared is 25. So 25 pi times by something over 360. Well, if I divided both sides by 25 pi, so let's divide both sides by 25 pi because this is non-calculator. So that would become 5 pi over 25 pi is the same as theta over 360. Now, what can I cancel out? Well, I could divide, pi over pi, and 5 over 25 would become a fifth. So a fifth equals theta over 360. So therefore, to work out what theta is, I would just do a fifth times by 360. So 360 divided by 5. Where can I do that? So 360 divided by 5. 5s into 3 are 0. 5s into 36 are 7. Remainder 1. And 5s into 10 are 2. So therefore theta, the angle, must be 72 degrees. Now that I know that, 72 degrees, I need to work out the size of the shaded area. So let's just get rid of this working. And this is going to be slightly trickier, but all we need to do is work out the area of the large circle, which we've already done. So we know that the area of the large one, area of large sector, is 5 pi, and now all we need to do is work out the area of the small sector. So how do you work out the area of a circle? You do pi times radius squared, but this isn't just a circle, it's a sector of a circle, so we have to multiply it by the fraction of the circle that it is. And actually I know that 72 over 360 is the same as a fifth, because I worked that out previously. So pi times radius squared times by a fifth. So 72 over 360 is the same as a fifth. So this is technically a fifth of the circle. And what's the radius here? Well, the radius for this part is 2. So I would do pi times 2 squared times by a fifth. And then that would simplify to 4 pi times a fifth, which I could write as 4 pi over 5, or 4/5 pi. So to calculate the size of the shaded area, I do the large area, take away the area of the small sector. So this area here is 4/5 pi. And this area here is 5 pi. So 5 pi take 4/5 pi is going to be 4 1/5 pi. And I could just leave it as that. So here I've got some vector geometry. So I have been told that I have a trapezium, and I've been told certain lengths of it. So LM, so with vectors, what's the key things that are important is that you can only travel by the routes that they've given you. So things that are represented by the vectors, and you always have to go along those routes, essentially. So LM is represented by 2M, LP is represented by 4L, so all of this is 4L, and MN, which is over here, is 3/4 of LP. Okay, so if I know that LP is 4L, and so vectors, all it means is that little line at the top is just showing you the direction. So LM just means how do you get from LM in that direction. If it was going in the other way, so if it was going this way, if it was ML, you'd write it like that, and the arrow would be in reverse. So that's all that vector notation is. Now you've got LP equals 4L, and you know that MN, so the line parallel to it, is 3/4 of 4L. So 4 divided by 4 is 1, times by 3 is 3. So therefore MN must be 3L. So I can write that here, 3L. So that's what I've worked out so far. Now it tells me that B is the midpoint of NP. Okay, so that's the midpoint of NP. So if I figure out what NP is, I can halve that to get to NB, and A is the point such that LA to AP is 1 to 3. So let's just ignore that, and let's just work out what we know so far. So let's figure out how I could work out NP. So a lot of people get confused with vectors because they read the whole question and they're like, I don't know what to do. Just work out the little bits that you can first. See the bits that the little information they've given you. So they've told you this, so you could work out that. Then you know that NP you're going to be using at some point. So let's just work out how we could do that. So 3L is obviously in this direction. Now, if we were to work out NP, how could we get from N to P? So how could we do this? Well, we can only travel along routes that have already been given to us. So we're going to have to go along this route here. Now it's going to be the reverse. So when you're doing the reverse, if this is 3L, going in the reverse direction is just going to be the negative. Okay, so that would be negative 3L. Going in the reverse of this as well. So that's going to be negative 2M. And thankfully, I'm going to go in the same direction. So that would be positive 4L. So NP can be written as minus 3L minus 2M plus 4L. I could simplify that. So minus 3 plus 4. So NP is L take 2M. Now, if I wanted to get to NB, so let's take all those away. NB is going to be half of whatever NP is, because if NP is L take M and NB is the midpoint, that means it's halfway there. So therefore NB is half L take M. Okay. I don't actually know if that's going to be useful. I always just try and work out the bits that I need. So let's see what's going on. So I need to find the vector AB. So this here, but I can only go along routes that I know. So the routes that I could take are this route here. So go along here and then up here. And actually that would be a lot easier. So yeah, to find the vector AB, I need to work out the vector AP plus the vector PB. Okay, so let's just get what we know. We know that NP is L take 2M. So therefore, if I went backwards, because if I wanted to work out what PN is, I would do 2m take L. I'm just going in the opposite direction, so I reverse the signs. And therefore, if I wanted to work out what PB is, because that's half of it, so actually I didn't need to do that working out, but it's fine because I've shown you how to do it. So PB would be half of that, so that would be M take half L. Okay, so this is all of the things that I've worked out so far. And let's just write them down. So that would be M take half L. Now LA to AP is 1 to 3. So that means that's 1 part to 3 parts, which means if that is 1, 2, 3, 4, it's split into 4 parts. That's 1 part to 3 parts, and all of it is 4L. That means 1 part would be L and 3 parts would be 3L. So this part here, this journey here would be 3L. So I know that AB is going to be AP, which is 3L, plus PB, which we worked out over here, is M take a half L. So therefore the vector AB is going to be, what can I simplify? 3L take a half L would be 2.5 L plus M. And that's how I do that one. So here I've got a question about perimeter. It's a slightly interesting question. It's not straightforward, I mean, but if we apply the rules of perimeter, then it should be pretty straightforward to figure out. So I'm told that here is a rectangle, and the 12-sided shape below is made using 4 of these rectangles, and I need to work out the perimeter of this new shape. So I want to use the lengths that I've already been given. So I know that the length is 8 centimeters and the width is 3 centimeters. So I can kind of like label that around and label the sides that I know. So actually I'm not going to label them centimeters. I'm just going to write them in numbers just for ease of easiness. So these are all the sides that I know. I also know that this length here and this length here is going to be 8, and then the sides that I have left to figure out that I don't know would be this part here, because perimeter is all the way around, and this part here. So actually I figured out a lot of the perimeter, because I know this would be 3, that would be 8, that would be 3, I don't know that little bit, this would be 8, don't know that little bit, that would be 3, 8, 3 and 8. So what I need to do is just figure out this little missing bit over here. So how can I do that? Well, I've got this large rectangle here, and I know that 2 of the rectangles are lined up inside of it. Now each of these little things here is going to be a length of 3, so therefore I know that this space here, or this length here, must be 6, and if the total is 8, that must mean that the leftover bit here and the leftover bit here must add up to make 2, because 8 takes 6 is 2. So it doesn't really matter. I mean, normally they might say that it's the shape has a line of symmetry, which means it would all be symmetrical, but in this case it doesn't matter, because even if this was 1.5 and that was 0.5, it still had to add up to 2. So the missing bits here, whatever they are, they have to add up to 2, just to make life easier. Let's call them 1 and 1. And then over here would be the same case, because this bit here is 6. So this bit here, whatever it is, means that I have 2 centimeters left over. So to work out the total perimeter, I'd do 3. So let's go around in a different color. And I would really recommend when doing something like this, especially if it's a 12-sided shape, to literally just trace it, just so you don't mess something off by accident. So 3 plus 8 plus 3 plus 1 plus 8 plus 1 plus 3. Oh, did I see? Even I missed a bit. So I was talking. Plus 1 plus 3 plus 8 plus 3 plus 1 plus 8 plus 1. And when you've completed it, you know that you've gone like all the way around. So let's simplify that. Let's just do all the numbers that are the same. So we've got 8, 16, 24, 32, 3, 6, 9, 12, and then 4. So 32 plus 12 is going to be 44, and 44 plus 4 is 48 centimetres. So the perimeter of this shape is 8 centimetres. Okay, so here I've been given a shape on a grid and I've been asked to enlarge it by a fractional scale factor. So when you're enlarging a shape, even though it says enlarge, it might actually mean that you're making it smaller, especially if it's a fractional enlargement. Enlarge just means like change the shape. It doesn't necessarily mean make it larger. So I'm told that I have to do this through the point 0, 1. So let's plot that there. And I want to enlarge shape A by scale factor a quarter. So what I do is, first of all, enlarging it by scale factor a quarter means it's going to be I'm multiplying each side by a quarter. So normally if it was scale factor 2, you'd double it, but it's scale factor a quarter, so you're multiplying it by a quarter, and multiplying by a quarter is the same as dividing by 4. So let's pick one point at a time. Let's pick this first point, the base of the trapezium. What I do is I find out what the distance is from the point they want me to go to one of the first points. So I go across 2 and then up 8. Okay, so across 2 and up 8. And not only am I making my sides like 4 times smaller, but also the distance from the point of enlargement needs to be a quarter of the distance. So let's say it was 2, 8. It would now need to be 2 divided by 4 and 8 divided by 4. It needs to be a quarter of the distance. So 2 divided by 4 is 0.5 or a half, and a half would be over here, and 8 divided by 4 is 2. So my new coordinate for this would be a half and 2. So a half and 2 would be over here. And then what I could do, I could try doing the other coordinates as well, or I could start drawing my shape. So I'll do a few more coordinates just so you can see what's going on. Okay, so this coordinate over here, let's see what the distance is. So it's, I go 1, 2, 3 across, and then that would be 12 down. So 3 across, 12 down, or up, or whatever. So I divide that by 4, so that would be 3/4 and 12 over 4. 3/4 is 0.75. So this isn't a particularly nice one. So 0.75 and 12 divided by 4 is 3. 0.75 and 3, so roughly there. Now, does this make sense? Because if I was enlarging the shape by a quarter, that means I'm dividing it by 4. So what is this original side? It's 1, 2, 3, 4. And this side here would also be, what 4 divided by 4 is 1. So I've made that shape a quarter of its size. Let's try a different point so that we can see where the base would be. So this point over here is 10, 9. So let's go across from our point of enlargement to 10. That's a distance of 10. And from 9, this is the worst straight line thing, from 9 to 1 is 8. So once again, let's divide everything by 4. 10 divided by 4 is 2.5. So that new coordinate would be 2.5, and 9 over 4, 8. Why am I saying 9? 8 over 4 is 2. So that point would be 2.5, which is here, 2. So I'm just going to get rid of all of the construction lines kind of there. So let's get rid of all of that. And can you see how this is now literally a quarter of the original shape? So I'm going to just join everything up. And then this new point here, I mean, let's just do it just for the sake of completion. So, sorry, I've got... so we start from 0, 1, we go across to 9, and down from 13 to 1. So that's across 9, and 13 to 1 is 12. So 9 divided by 4. So that's not going to be a very nice number to do on this axis, but it would be 2.25, and then 12 divided by 4 is 3. So 2.25 and 3, and it's going to be here. So just join it up like this. Now Normally it would say name the shape B or whatever, but here we go. That's how I'd do a scale factor, a fractional scale factor. So the key thing is it needs to be a quarter of the distance that it now currently is from each point from the center of enlargement, and it needs to be a quarter of the size. So here I've got a question on pressure. Now the formula for pressure is force over area. So I'm told that a camera with a rectangular base is placed on a table. So let's just imagine that's the base of the camera. The base of the camera has length 4 centimeters and width 5 centimeters. So 5 centimeters, 4 centimeters. The force exerted on the table is 100 newtons, and I need to work out the pressure in newtons per meter squared. Okay, so this is not a trick question, but be very, very, very mindful of questions like these because your units have been given in centimeters and your answer is in meters squared. So first of all, let's work out the area. So the area would be 5 times 4, which is 20 centimeters squared. The pressure, no, the force is 100 newtons and the area is 20 centimeters squared, but that needs to be in meters squared. So 20 centimeters squared into meters squared. Let's just think about how we'd do this. So if I said a meter squared, 1 meter squared, that's just 1 meter by 1 meter by 1 meter. But if I were to turn it into centimeters, that would be 100 times 100. So obviously 1 meter squared is 1 times 1 is 1 meter squared, but 100 centimeters is the equivalent of 1 meter, and 100 times 100 is 10,000. So 1 meter squared is actually 10,000 centimeters squared. So I need to work out what 20 centimeters squared is in meters. And how do I go from 10,000 to 1? Well, I divide by 10,000. So I'd need to do 20 divided by 10,000. What would that become? That would become 2 over 1,000, which would become, divided by 2, 1 over 500. So 1 divided, sorry, 1 divided by 500 would be 0.002. Or I could have just done 2 divided by 1,000, whichever you find easier. So yeah, so that would be 0.002 meters squared. So I would do the force that I've been given, which is 100. Oh, that's a strange colour. That's not what I chose, but okay. So 100 divided by 0.002. And actually, because I'm working in a non-calculator, I could have just kept that as I just rubbed it out. What was it? 1 over 500. So I'm doing 100 divided by 0.002, which is 1 over 500. What do you do to divide fractions? Keep, change, flip. So that would be 100 times by 500 over 1 over 1. So that would be, in total, the pressure would be 50,000 newtons per meter squared. Right. Okay, so in this question we've got two sets of ratio that have one variable in common. And we need to write it in the ratio A to B to C. So what I'm going to do in this case is just set up a little table so that I can see how everything is related to everything else. So I've got A to B to C. So I know that A to B is 9 to 4. And I also know that separately that B to C is 6 to 13. And what I want to do is, this is my variable in common. So I want to think to myself, okay, how can I make that so that it's equivalent for both of them? And the way to do that is by working out the lowest common factor. So in this case, that would be 12. So I want to think to myself, okay, this whole ratio over here, I want to multiply by 3 because 4 times 3 would give me 12. So let's times that by 3 and I've got a new ratio. That would become 9 times 3 is 18 to 12. And then I do the same here, except what do I multiply 6 by to get to 12? I multiply that by 2. So if I multiply that by 2, I need to multiply this by 2. To keep ratios like in the same ratio, you need to multiply each part of the ratio by the same amount if you're going to be altering it. So 13 times 2 is 26. I mean, I could have written it like that, 12 to 26. And then you're like, okay, it's in the same ratio. So I can write them as 18 to 12 to 26. And it says give your ratio in its simplest form. So what I want to do is find common factors of everything. So let's just start by dividing by 2. So that'd be 9 to 6 to 13. And 13 is a prime number, so you're not going to simplify it any further. So there we go. That's how we do that one. So in this question, I'm being asked to write a ratio in its simplest form. So in order for it to be in its simplest form, it needs to be in an integer format. So you don't want decimals. So I've got 1.6 to 5. And what I want to do is basically turn this 1.6 into a whole number. So I know that 1.6 is a kind of, you know, if I times it by 10, it's similar to the 16 times tables. So I'm just going to write out the 16 times table. So 16, 32, 48, 70, 96, blah, 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 blah. What I'm looking for is a whole number. So if I divided those by 10, that'd be 1.6, 3.2, 4.8, 7.0, 9.6. And I don't need to go any further because 7 is a whole number. So what do I multiply 1.6 by to get to 7? Or times by 2 is 3.2, times by 3, times by 4. So 1.6, if I times that by 4, that is going to give me a whole number. And that would be the whole number of 7. And to keep the ratios equivalent, I need to multiply 5 by 4 as well. So that would be 7 to 20 in its simplest form. Next, I've got ratio and variable. So this is where I've got to use a little bit of algebra in my working out. So James, William and Scarlett share £49. William gets twice as much money as James and Scarlett gets twice as much money as William. So James seems to be the common variable. So let's say James is X. We're just going to give him a variable. William gets twice as much money as James. So if James is X, William is going to be double this. So that's 2 times by X, which would be simplified to 2X. And then Scarlett gets twice as much money as William. So Scarlett would be double whatever William is. So it would be 2 times by 2x, and that would simplify to 4x. So here I've got my algebraic kind of breakdown. So I know that James plus William plus Scarlett, all of that adds up to make £49. Oh, that's supposed to say 49. So let's simplify that. X plus 2x plus 4x is 7x. 7x is £49, which means that x is £7. So one part, or x, is £7. And I know that James just has one part. So James is x, which is £7. So I need to work out how much money Scarlett gets. Well, I know that x is 7 and Scarlett is 4x, or represents 4x. So I'm going to do 4 times by 7, which is £28. And that's how I do that question. So in this question, I'm dealing with direct proportion. Now, when you're dealing with direct or inverse proportion, it's really good to just write your statement of proportionality. So I know that y is directly proportional to x. This little sign here means directly proportional to. So when x is 400, y is 8. So I've got my statement of proportionality, and what I want to do is turn that into a formula. Now, when I say y is proportional to x, it means so if I just use the example of Mars bars, if a Mars bar costs 20p, 1 Mars bar is 20p, 10 Mars bars would be 10 times 20p. So I have like k represents your constant. It represents like the cost per unit kind of. So that is what it's being multiplied. If I just said y equals x, then that would mean that there's no way of figuring out how much like 10 lots of it would be. So that's my statement of proportionality, but then written as a formula, I'm going to introduce my constant, which is k. So once I've got this formula, y equals kx, I can substitute the values that I have been given. If it was inverse proportion, it would be y equals k over x, but we'll get onto that for an inverse proportional statement. So when x is 400, y is 8. So I'm going to say 8 equals k times 400. And in order to work out what the value of k is, so 8 over 400 equals k. Can I simplify that? Yeah. So k would be, I could simplify it, 4 over 200, which is 2 over 100, which is 1 over 50. So k is 1 over 50. So I've worked out what k is, and now I need to write a formula for y in terms of x. So I know k is a 50th, so I just say a 50th x, or I could write that as y equals x over 50. That would be better. So that's how I work out a formula. I write my statement of proportionality. If it's in direct proportion, you're always going to use this formula, y equals kx, and then you just substitute the values that you've been given in to figure out what the value of k is, and then substitute that back into the original formula. So y equals a 50th x. Now here we've got inverse proportion. So similarly, I would write the inverse proportion statement. So the force between two magnets is inversely proportional to the square of the distance between them. So in this case, it wouldn't be y, it would be F is proportional to the inverse of the square of the distance between them. So x squared. To write that as a formula, that would be F equals k over x squared. So let's substitute the values in. I don't know why that says expression. It should be a formula, but hey, whatever. So F, when F is 6, x is 5. So that would be 6 equals k over 5 squared. And 6 equals k over 25. And then 25 times 6 is going to give me my value of k. So k equals 25 times 6, which is 150. So therefore, the formula, if I know that k is 150, I would write that as F equals 150 over x squared. So that's my formula. Now I need to work out the value of F when x is 10. So F equals, I'm going to use the formula, 150 over 10 squared. So F is 150 over 100, which would be 15 over 10, which is 1.5. So that would be 1.5. And then I need to work out the value of x when F is 50. So I use my formula. 30 equals k, which is 150 over x squared. I rearrange it, so multiply both sides by x squared. So 30x squared equals 150. So then x squared equals 150 over 30 if I divided both sides by 30. And 150 over 30 is the same as 15 over 3, which is 5. So x is going to be the square root of 5. And that's how I do that. Okay, so here I've been given a mean question. It's I haven't been given all of the values. I've just been told what the mean of some of them are. So the mean of 4 numbers is 3. So I've got 1, 2, 3, 4 numbers. I don't know what any of them are. That's a lie. I know that one of the 4 numbers is 4. Okay. So the mean of 4 numbers is 3. So 4 plus x plus y plus z divided by 4 equals 3. So how do we work out the mean? We use the sum of the values and we divide that by the number of values. So that's why I did 4 plus unknown, 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 divided by 4 because there's 4 values equals 3 because that's what I've been told. So then I know 4 plus x plus y plus z, I've just called them x, y, z because I don't know what they are, equals 12 because I multiplied both sides by 4, just rearranged it. And therefore x plus y plus z must be 12 take 4, which is 8. Okay, so these numbers must add to make 8. And I need to find the mean of the other 3 numbers. Well, how do you work out the mean? It's the sum of the values divided by the number of values. And what's the sum of the values? I know that they all add up to make 8. And I know there's 3 of them. So the mean would be 8 over 3. Because this is a non-calculator paper, you don't need to generally. I mean, they haven't really specified, so let's just do it. 8 divided by 3. Let's do it over here. So how many 3's go into 8? 2. Put your decimal points. 2, remainder 2. How many 3's go into 20? 6, remainder 2. How many 3's go into 20? 6, remainder 2. Okay, so 8 divided by 3 is going to be a recurring decimal. So we'd say the mean is 2.6 recurring. And that's how we do that. So in this question, I have a cumulative frequency table and I'm being asked to draw the graph. So note here that here I'm just provided with the frequency. So what I'm going to want to do is either, if they haven't given me like this extra table, I would just draw an extra column and then do the cumulative frequency. I always say it wrong, cumulative, yeah, whatever. So between 0 and 3 kilograms, there are 15 koala bears that weigh that. Between 3 and 6, I'm going to have to add them because cumulative means like the running total. So you add everything that's gone before. So 15 plus 10 is 25. And then between 6 and 9, I'm going to do 25 plus 45, so that would be 60 plus 10, which is 70. And I know there are 90 koala bears in total, so that must mean the little missing bit that I haven't been given must be 20. I mean, the missing parts must be 20, but they are going to add up to make 90. So now I need to draw the cumulative frequency graph. So the weight goes from 0 to 12, so I'm going to label this axis here weight, and the frequency goes from, well, 0 to 90, so this would be the frequency, so the number of koala bears over here. So draw the cumulative frequency graph. I always plot it against the end of the range against the cumulative frequency. So that first point is going to be 315. The second point would be 625. Third point would be 970. And the last point would be 1290. So you always plot against the upper range of your class that you've been given. So 315 here, 625, this is such a terrible graph. Be roughly there. 970 would be here, and then 1290 would be there. Okay, so your cumulative frequency graph is always going to kind of like look like an S. So that's how we draw that. Now, we're being asked to estimate the interquartile range for the weight of the koala bears. Okay, so the interquartile range essentially means the upper quartile, take away the lower quartile. The upper quartile is like the 75% mark, and the lower quartile is the 25% mark. So what we want to do is work out the 3/4. 3/4 of 90. So 90 divided by 4 times by 3. Hold on. We're trying to work out the, let me read this because I'm feeling really not with it. Estimate the interquartile range for the weight of the koalas. So we want to look at how many koalas we have. We've got 90. We want to work out the upper quartile. So 90 divided by 4 is going to be 22.5. And then times it by 3 is going to be 67.5. Okay, so the upper quartile is 67.5 and the lower quartile would be 22.5. Now this, I think the numbers are not great. In a non-calculator it's going to be better numbers. So the upper quartile is 67.5, so that's roughly here. So I go from there to my line. The lower quartile is 22.5, so roughly there. And then once I get to the cumulative frequency, I go along and then down. And here. Okay, so let's say that's 8.6 over here, and that would be 6. So the interquartile range for the koala bears would be 8.6 take 6, which is 2.6 kilograms. So the interquartile range is the upper quartile, take the lower quartile. You work out the upper quartile of the frequency and the lower quartile of the frequency, go along to the graph and read what that would be on the axes. And it says estimate the number of koalas that weigh more than 10 kilograms. So what I do is I go to 10 kilograms and I go up to my graph and across, and that's, we're going to say roughly 80. So 80 koalas weigh less than 10 kilograms, because that's the cumulative frequency, which must mean that 10 koalas weigh more than 10 kilograms, because that's this bit here. And that's how we do that. Okay, so in this question I'm being asked to draw a Venn diagram, and in this case it's a 3 kind of layered diagram, so it's a little bit tricky. Alfie asked 50 people which sports they like, from swimming, tennis and volleyball. So let's just draw our Venn diagram here. So we've got it there. Not equal, but oh well. So that would be swimming, tennis and volleyball. All 50 people liked at least one of the sports. So everyone liked one of the sports, so everyone's going to fit inside the Venn diagram. 18 people liked all 3 sports. So this is going to be the little cross section that all 3 circles intersect. So that's going to be where I'm going to put 18, because that covers every single person. 15 people liked volleyball and tennis, but do not like swimming. So they can only intersect volleyball and tennis. So that would be this part here. Okay, so that's where I'm going to put 15 people. 22 people like tennis and swimming. So that's this section here. Except this is where you need to be really careful, because 22 people like tennis and swimming. That means that all of this because it doesn't say they don't like volleyball. So 22 people like tennis and swimming. This is the bit that intersects for tennis and swimming. So all of this adds up to 22. 18 has already been put in there. So 22 take 18 is 4. Then we know that 25 people like swimming and volleyball. So this is the section, let me use a different colour. This is the section for swimming and volleyball. So once again, all of that must add up to 25, but I've got 18 in the middle. So 25 take 18 is 7. 41 people like volleyball. So all of this must add up to make 41 people. So 41, 18 plus 7 is going to be 25. And 25 plus 15 is 40. So all of this little circle must add up to 41, but these parts add up to 40. So therefore, that's just going to be one person in here that I put. And then it says 3 people like only tennis. So I'm going to put that in here. And then the remainder, so I know that everything needs to add up to 50. So I know that this whole circle here, the volleyball circle, is 41. Plus 3 plus 4 is 48. So that gives me a remainder of 2 people. So that must mean only 2 people like only swimming. So that's how I'd complete the Venn diagram. Now I need to work out the probability that this person likes swimming. Well, if it was only swimming, it would be 2 out of 50, but swimming, everyone inside this circle here likes swimming. So 18 plus 4 plus 7 plus 2. That would be 20 plus 11, which is 31. So the probability that someone likes swimming would be 31 out of 50. Then it says given, now this is where a lot of people get confused with probability. So it says given that the person selected at random likes swimming. So if it's given, it means it's only out of the people that like swimming. So we know that's 31 people in total. So that's going to be what my probability is out of. So given that the person selected likes swimming, find the probability that this person also likes exactly one other sport. That's supposed to say, I don't know what it says, drink. Sport. So also likes one other sport. So they like swimming, so it's going to be out of 31. And if they liked one other sport, it can either be this section here or this section here, because this bit here means they like all 3. So 7 plus 4 is 11. So that would be the probability, 11 out of 31. If they only like swimming, that's this part here. If they liked all 3, that's, didn't mean to do that, that's 18. Whereas 4 people like tennis and swimming, and 7 people like volleyball and swimming. So that would be 11 out of a total of 31. And that's how we do that question. Okay, so final question. So here I'm being told that Freya is looking at a wedding menu. There are 5 starters, 4 mains, 3 desserts to choose from for the wedding menu. In how many ways can these menus be combined? So essentially what that means is she's got 5 starters. So starter, 2, 3, 4, 5. And each of these starters can be combined with 4 mains. I'm not going to draw all of them. I'm just going to do one as an example. And then each of these mains can be combined with 3 desserts. Okay, so imagine each of these mains kind of like looking like a weird sort of futuristic kind of tentacle weird thing. But anyway, imagine that happening. So essentially for every starter, you can have 4 mains and 3 desserts for each of those. So when I've got something like this is called the product rule for counting. When I've got a series of combinations and I'm just wondering what I need to do, I essentially just multiply everything, because I've got 5 options that I can combine with 4 mains, and each of those 4 mains I can combine with 3 desserts. So what would I do? I do 5 times 4, which is 20, times 3, which is 60. So in total, there are 60 ways you combine the main with a dessert, and so forth and so forth. So yeah, that's it. So that's all for now. All of this was non-calculator paper things. So if there's anything that you didn't quite get, just drop a comment and I'll go through it in more detail in a separate video. But hopefully you found that helpful.